Hello all, in this video I am going to solve question number 26A and B from CBSE class 10 standard math 2026 board paper. The question paper code is 30/2/3. The part A of question 26 says prove that the lengths of the tangents drawn from an external point to a circle are equal. Let's draw a rough sketch of a circle with center O. Let T be a point outside the circle. PA and TB are the tangents to the circle touching the circle at A and B. Now join OA and OB. Here angle OAT and OBT are 90 degrees. That is these two angles. The reason being radius is perpendicular to the tangent at the point of contact. Let's join OT. If we prove the congruencies of these two triangles, that is triangle AOT and triangle BOT, then we can prove that the length AT is equal to BT. In triangle AOT and triangle BOT, OT is the common side and it serves as the hypotenuse for both the triangles. And angle OAT is equal to angle OBT is equal to 90 degree. We have given the reason already. OA is equal to OB. Both are the radii of the same circle. By RHS criteria, triangle AOT is congruent to triangle BOT. Therefore, AT is equal to BT. So we have proved that the tangents drawn from an external point to a circle are equal in length. Hence, proved. The B part of the question says, two tangents TP and TQ are drawn to a circle with center O from an external point T. Prove that angle PTQ is equal to twice angle OPQ. Let's draw a rough sketch of a circle with center O. T is the external point. TP and TQ are two tangents touching the circle at P and Q. Here we have to prove that angle PTQ is equal to twice angle OPQ. This is angle PTQ is equal to twice angle OPQ. OPQ is this angle. Here we know that angle OPT, that is this angle, and angle OQT, this angle, is equal to 90 degree. The reason being radius is perpendicular to the tangent at the point of contact. In quadrilateral POQT, angle OPT plus angle OQT plus angle POQ plus angle PTQ is 360 degree. OPT is 90 and OQT is also 90. POQ plus angle PTQ is 360. Angle POQ plus PTQ is 360 minus 180, which is 180. Let's keep it as equation 1. In the to prove statement, we have PTQ. So we have to retain this PTQ, but we don't see a POQ in the to prove statement. That is, this angle has to be replaced with OPQ. Now let us get into this small triangle POQ. Here OP is equal to OQ. They both are the radii of this circle, which means that triangle POQ is isosceles, which implies that angle OPQ is equal to angle OQP. So that is, I am talking about these two angles. Now in that small triangle POQ, the sum of the angles is equal to 180. That is angle POQ plus angle OPQ plus angle OQP is equal to 180. Now that we need OPQ, let's replace OQP with OPQ and the rest remains the same. So angle POQ is equal to 180 minus 2 times angle OPQ. Let this be equation 2. Substituting the equation 2 in equation 1. Instead of angle POQ, let's write this 180 minus 2 times angle OPQ plus PTQ is equal to 180. 180 gets cancelled. Therefore, PTQ is equal to twice angle OPQ. So this is a statement that we had to prove, hence proved. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.